Okay, so our next video will be pump head. So pump head. So in marine engineering, pump heads refer to the energy per unit weight of the fluid that pump imparts to move the fluid. So it is expressed as the height of a column of liquid that the pump can lift or move against gravity. And it is crucial for the efficient operation of the pump and the system it is serving. So the concept of hydrostatic head plays a significant role in pump design and operation. So let's continue. So hydrostatic head, we have different um, types of hydrostatic head. First, we have the static head. So static head is the difference in elevation between the surface of the fluid and the point at which the pump is discharging the fluid. So it represents the height of the pump must overcome to push the fluid from a lower to a higher elevation. And then we have the dynamic head. So static head. So we have dynamic head refer to additional head generated by the pump when it is moving the fluid, accounting for factors such as friction losses, flow velocity, and pipe characteristics. So this head is related to the energy required to overcome resistance in the piping system. And then we have the total head, which is the sum of the static head and the dynamic head. Okay, for pump performance and characteristics, the design or select an appropriate pump for a marine system. So we have this diagram. So we have the pump curve. This red one is a pump curve. So and we have the system curve. The pump curve is given by the manufacturer of the pump. So they will calculate the pump curve of your their pump what's we call it, their pumps. Okay, and then depending on our system on board, so we have the system curve. So if you have different pipes, you have also different system curve. And then so using this diagram, depending on which part of both the system curve and the pump curve meets, so you will get the value of your flow rate. So if you get the value of flow rate, now you can order what kind of pump or what flow rate of pump you will be using on board. Okay, so this calculation usually is used in our shipbuilders and system builders. Okay, so example calculation of pump head. So we will just simplify this one later. Okay, so what are the applications of pump heads in marine engineering? First is for ballast water management, for our fuel oil transfers, for cooling systems in our engines, for freshwater distribution all over on board, for our showers, for our tap waters, or for our tank cleaning devices. So we will be using also pump heads. And for bilge water pumps, so bilge is removing water and oil from the lowest part of the ship. That is what bilge water. So this pump must overcome the hydrostatic head created by the water in the bilge and effectively pump out any water that accumulates. So you will be pump head is very important in our daily use of our pumps on board ships. Okay, so let's go how to calculate. Okay, so we have a suction lift or suction head. So suction head is usually at the suction part of our pump. If this is your pump, the blue one, so you have a suction on this one. So if your suction is below your pump, you have a negative suction. But if your suction is above your pump, for example, there is a tank on above your pump, and then you will be sucking the liquid, so you have a positive suction. If the suction is in line with your ship, you have a zero neutral suction. Okay, and then you also have losses during your suction, depending on your pipes, depending on how big your pipes is, there are many curves in your pipes, so there are also losses in that one. And then we have also the discharge head on this part. So it is on the discharge side of the pump. So usually the discharge head is positive because it always goes up. Okay, so discharge head, but you will have a losses depending on the friction of the liquid, your pipe curves, or how big your pipe is. So there are restrictions or losses that might happen. So that will be negative. Okay, so in computing your total head, you must add both the suction head and the discharge head, including all the losses. Okay, so we have a given data here. We have a static suction lift of 3 meters, discharge head of 15 meters, friction loss in the suction line of 2 meters and friction loss in the discharge line of 5 meters. So if you will have to compute this one, so this one is incorrect. So if you will have to compute this one, we have to add negative 3 on our suction lift, so because the suction is, as you can see, the suction is transfer seawater from a lower reservoir. So as you can see that the lower reservoir means that your pump is above your suction tank. Okay, so that is negative suction, as you can see. Okay, that is 3 meters of negative suction. So that is negative 3 meters. Minus the friction loss in the suction line, since losses are negative also, so you will have negative 3 minus 2 meters. Plus the discharge part of the discharge head, which is 15 meters plus 15 meters, minus the friction loss in the discharge line, which is 5 meters. So negative 3 minus 2 plus 15 minus 5, so that will equal to 5 meters. So your total head will be 5 meters. So this one is a wrong computation because they are not using negative on their measurement. So this is 3 plus 2, 5 meters, negative 5. That should be negative 5. And then 15 minus 5 of meter of loss. So that should be 10 meters. So 10 meters minus 5 meters, or negative 5 plus 10 is equals to 5 meters. So this one is incorrect. So that's how simple you just calculate your total head of your pump. Okay, that's it. So I hope you learned something today, and we don't know yet what is our next video, so I hope you learned something today, and I'll see you on our next video. God bless and have a great day, everyone.